So then, good morning, everybody. First of all, thank you for turning up relatively early. If you drove, congratulations on making it through into the car parks. If, like me, you probably had to fight your way past the guy with the clipboard. But what you're here to do today is to hear from a range of industry leaders from software, hardware, focused on design visualization and VR. Now, the bad news is you've kind of got me in the middle of all the presentations today. So no Rob Jamieson. Feel free to cheer if you want to. But you do have me. So what we're going to do to start off with is we are running 5 minutes late. So I've cut into Chris's time already. But we're going to run through some of the latest offerings from AMD that you might not be familiar with. But before I do that, I should probably introduce myself. So my name is Jamie Gwilliam. My email address is there if you want to send me any abuse or any tips on how to present. That's my email address. And if you're on Twitter, then that's also there for you. So if there's any questions that you want to ask today and didn't have a chance, please get in touch. We're always traveling around. We're always happy to come and visit you. So to start off with, AMD might be a brand that you're familiar with, but the background, the ethos to AMD is hopefully we inspire innovations everywhere, which sounds great, but obviously we need to have some substance behind it. So at AMD, if you have a thin client, you're going to be using AMD technology. Almost 70% of the thin clients out there are powered by AMD. If you've been to Broadway recently, most of the big screens that you're seeing in one particular case, the same size as an Olympic swimming pool, again, are powered by AMD GPUs. So you can see kind of the power that they can output and the beast of technology that's inside of those GPUs. And of course, you know, we're probably at your desk if you're working with any of the latest hardware and software. But more importantly than that, next time you're flying on a Boeing, then AMD technology is in there in the navigation systems to make sure it stays up in the air, which I believe is a good thing with aeroplanes. The other thing that you might not be aware of, and which really ties into the rest of the day, is any of the major consoles, so the PlayStation 1, the Xbox, then we're actually inside of those, powering everything that's displayed on screen. And as you know, they are very, very visually kind of demanding with regards to the quality that is outputted from those two particular consoles. So you're probably using AMD technology without even realizing. But what I want to do first off is show you one video. It's a very short video, and it's just going to give you an idea of how some of our customers use AMD technology with HP. So let's have a quick look at this video.
We won the British F3 5 times with Jonathan Palmer, Ayrton Senna, Mauricio Gugelmin, Mika Hakkinen and Rubens Barrichello. But also alongside them we had guys like Eddie Irvine, Alan McNish and lots of other top drivers. We then moved into British touring cars, super touring it was. We've been involved in it right from day one. You have to be really on top of your game to win.
The main thing about touring car racing is very competitive. You know, you have 25 cars split by a second in qualifying. So to get in the top 5, you're talking hundreds of a second to get on pole position. So we're always trying to find that extra advantage over the other teams in the pit lane. We're constantly trying to think of new ideas, and we can see where the problems are with the car from the data we receive off the onboard logger. And then we go back and start looking at areas to develop, whether it's reducing the drag of the car or making it a better environment for the driver. So we take the stock road car, it gets stripped back to its bare shell, and then we rebuild it as a bespoke racing car, precision engineering. So what's important for me as an engineer is using the latest technology available. The faster we can do things on the computer, the faster we can get out on track and test stuff. And to be able to do this, we need to use the best kit. And so using an HP workstation, the RADEON Pro WX graphics card, has really made a difference that we can do things much quicker now in the workshop, analyse things and come up with new things to test and improve the performance of the race car. The latest tech is so important to keep ahead of the game and ultimately make the car go quicker and win the championship.
So it's just one short example of how some of our local customers are using AMD technology in their designs and manufacture. We are always looking for customers to highlight. So if there's any particular work that you're doing that you're really proud of, then make sure you either speak to myself or Rob Jamieson, who just hid round the back. He tends to do that when there's any talk about work. He often hides. But feel free to speak to myself or Rob if there's any work that you want to highlight to be the next customer testimonial video. But anyway, in a nutshell, what that basically means is AMD is absolutely great today. You know, we have a broad range of different manufacturers that trust in the AMD GPU brand, the stability and the reliability that they bring to the systems. And you wouldn't see that from any of the console manufacturers if they didn't have that same level of trust. And of course, we're powering some of the latest big media walls and presentations. But what I want to do, obviously, is focus on what we're here to talk about today, the design visualization, ultimately making those pretty pixels. So at AMD, we have some technology which we're going to discuss in a second, but we're also making sure we partner with whatever render engine or games engine that you're working with. So the two that's worth highlighting is Octane Render and V-Ray from Chaos Group. If you're working with any of those render engines, then they actively work with us to make sure you get the best possible performance out of that GPU. And as we all know, GPUs are very, very efficient at processing data, much more efficient than CPUs. So if you invest in anything, I'm going to be a little bit biased, but if you invest in anything, make sure it's the GPU. Your renders will definitely benefit. Now, we've got a couple of open source solutions that we're going to talk about in a second, and you might not have heard of them, so PRORENDER from AMD. But before I do that, I just want to kind of emphasize the point I was making, particularly if you look at Chaos Group's V-Ray. If you're working with some of the latest AMD GPUs, then you're going to see a massive performance increase. And I promise you're not going to get too many benchmarks and presentation kind of slides today, but it's definitely worth highlighting that you are going to see a huge speed improvement if you're working with the latest AMD GPUs. But let's jump back to what I wanted to talk about. So ProRender from AMD. An example of what we can do, hopefully you agree, it's a fully fledged render engine looking at these results. But if you're working with any of these applications, so Rhino, 3ds Max and Maya from Autodesk, SolidWorks, Blender, or even Maxon Cinema 4D, then ProRender will work with those software tools. And in some of those cases, in particular Cinema 4D, it will be their render engine that actually ships with the product. So again, that kind of shows you some of the trust that Maxon has in what we're doing with ProRender, our render engine. But ProRender falls under the professional banner at AMD, which is the RADEON Pro. And WX is our latest range of graphics cards. There will be a test, so if you're making notes, WX is certainly one of the things to write down. But I'm not going to go through all the cards in detail. But what I do want to do is just highlight kind of the top ones that are going to make a difference to your particular workflows. And the hero boy, as Chris will be able to kind of back me up on, is this one, the WX7100. Now this has an impressive 8 gigabytes of RAM on the graphics card. It's the world's fastest single slot GPU. So it doesn't take up much space in your actual workstation, but it does give you a lot of oomph. And oomph is a technical term, just in case you're not familiar with it, when you're doing renders. But a quick overview of what they are. The three main ones you need to know. WX7100, as I said, the world's fastest card, and VR Ready, which we're going to discuss in a minute. The mid-range, which is the 5100, again, a very good card if you're doing any kind of games engine work with any of the games engines out there on the market, and later on you'll hear from Chris at Unreal. And then we've got the entry level, the 4100. Personally, if you're doing lots of heavy rendering, then the 7100 is going to be the tool of choice for you. Now, some of the trends that we're seeing out there at the moment from all different manufacturers and different vendors is these four kind of key topics. So HDR, which I'm going to go into in a second, but ultimately 8K resolution. So most of the major software vendors and companies like Amazon and Netflix are pushing 8K as the standard render size. So we've all got used to doing 4K and the massive demands that has with renders and presentations. That's last year. 8K is now the future. Combined with HDR, which we're going to discuss in a second, obviously that's very, very demanding and creates a huge amount of bottlenecks. And this is where kind of being efficient with the tools that you have are really going to pay dividends. Liquid VR, which I'll discuss in a minute, and then the encoding and decoding systems. But Liquid VR in particular is an AMD RADEON technology that allows you to create audio or VR experiences in an intelligent and optimized way, which I'll explain in a second. But the one thing that's definitely worth discussing in kind of more detail is HDR. So HDR, high dynamic range, is a standard that's being pushed, in particular in the media and entertainment space. Now that's important because it always trickles down to the other industries. So if you look at what Amazon and Netflix are doing, any TV programs or films that are made at the moment have to be 8K and HDR to give you a much higher fidelity. Now, the reason that's important is the 7100 card, again, my favorite card, will power 4 of these HP Dreamcolor 27 and 32-inch displays just off the one card. Now, that's great because HDR gives you over 1 billion ranges of color. So I've been told not to move from this place, but if you look at the color chart on the left-hand side, you'll see this banding process, which is what you're used to with a typical monitor, an 8-bit display. With the 7100 card and HP Dreamcolor monitors, you get a much more graduated, realistic effect of the lighting, so you don't get any of this horrible banding. And that's giving you 1 billion different pixels and color range. So HDR is definitely something to think about if you're doing any particular renders or presentations. So let's jump back to ProRender. Let's go into this in a bit more detail. So ProRender is our render engine. There's a number of things that you kind of need to know about it first. First off, even though it's coming from AMD, it's not just GPU specific. It does a nice way of balancing between GPU and CPU. So even if you're running a non-AMD GPU, obviously you'd be very stupid to do that, but if you were doing it, it will still run as a render engine. And if you have a very old card, it will start throwing some of that data towards the CPU to give you an optimized render output. So it does a really intelligent way of balancing between the two. PBR shaders, or physically correct shaders, are kind of the norm now in any particular software or render engine, and of course ProRender will use that. It will also allow you to convert any of your V-Ray materials and bring them across to ProRender, and it will also take some of the Corona materials and any of the standard Autodesk materials that you have as well, and use those straight away inside of ProRender. So as you can see, it has a broad range of materials in it. Goes without saying that it's fast and accurate because we go back to what I was saying a second ago, where it's using the GPU, which is the fastest way of producing an image. But most importantly, the ethos at AMD is to use open standards. So what we're doing, we're partnering with other software vendors to make sure that everybody can benefit, and it's not a closed book. As you would expect with any fully fledged render engine, it has photorealistic camera effects. So in this particular case, the bokeh depth of field effect you can see on the right-hand side over here on this screen, all of these effects are built into the cameras, whatever cameras you're using in the software, to give you the effects that you would expect from a render engine, and most importantly, what your end client expects from a render. Now, if we look at kind of the materials just for a second, you can see that all the standard materials that you would expect, again, no matter what software you're working with, 3ds Max, Maya, Cinema 4D, Rhino, and even Blender, will work inside of it. And of course, you have the flexibility to use a shader network to make your own materials. But to get you off and going using this OpenCL renderer, if there's one thing you write down today, then it's this link at the top. So we've already created a package of materials, so you can start working with all the standard materials that you can work with, the carbon fibers, the steels, the aluminiums, everything that you would expect you can download from GitHub. Now, how long would you say that would take to make? It's a 1280 image by 720. In this particular case, it was made with 3ds Max, but it's irrelevant around the software it's made with. This particular image, how long would you say? A little bit dark on the projector, but who's having a guess? I'm only checking you're awake and you've had coffee. 5 minutes, did you say, Chris? No, it's not 5 minutes, Chris. Thanks for joining in. So this particular image took just 5 seconds to render. So 1280, 720 image, and that's because it uses an iterative rendering technique, which is very difficult to say in a presentation. But what that means is the image on the left took 5 seconds, and you can see it's a pixelated image. But what it does is it builds it up in stages. So if we were to leave it for just another 25 seconds, you see we end up with the image on the right. So the longer you leave it, the better quality you get. And ultimately, that means you can remove that kind of test render process where you set it off, have a look at it, check it's right, and then you have to start the final render. Because it's iterative rendering, it builds up that image, and simply the longer you leave it, the better image you get. Now, to kind of emphasize that a little bit further, this particular image, again, 1280 by 720, so decent resolution. With just 10 passes, and we're looking at 0.1 second a pass, you can see how that very quickly builds up. So the next time you go and have your cigarette or coffee break, just leave the renders running and you'll have a nice quality image that you can come back to after that 30-minute break. Now, that's kind of ProRender. Now, the nice thing about ProRender is AMD has a very deep understanding about VR. So when they come up with a render engine, they also include VR cameras. So we have a full 360 camera with inside a ProRender as well. Because ultimately, we know that no matter what industry you're working in, you need to be VR ready. Now, I'm going to come back to the VR side in a second to give you some quick examples. But before I do, I just want to kind of emphasize how ProRender works inside of some of the more popular applications. So in this case, Rhino. So again, it's using this OpenCL, ray tracing and iterative rendering. But more importantly, with Rhino, they've embedded this into the viewport. So you don't have any of these floating windows where you have to hit the big render button. It's straight away inside of the viewport. So again, you always see your model when you're doing your NURBS modeling in the most realistic way possible. And that's because they're using this OpenCL technology. Now, with SolidWorks, you're going to have an example later on from Chris in a second, where he's going to take you through the process of taking SolidWorks data, using ProRender, it's going to be a converter, and output it to Epic's Unreal Engine. Now, I would recommend that you go and have a look at the HP stand and the AMD stand to see Unreal running. And in particular, they've got a really nice example, which I believe was done by Burroughs in the UK, of the McLaren. And that's a really good example of what Unreal can do if you've not seen it in action. So, as we said, ProRender, AMD GPU cards, we work with all the major software vendors to make sure that you have confidence in what those graphics cards can do. Now, so much so, just want to reiterate that Cinema 4D now have introduced ProRender as their default render engine. And again, this gives you a good idea of the type of quality you can get, because it's probably not a render engine you've heard of, but I hope you agree that the results you get out of the box are definitely worth your time having a look at it. But most importantly, and this probably is the most important thing about ProRender, is it's free. So if you want to download it, have a play with it, I'd certainly recommend you do that. So, as I was mentioning, most of the major hardware that you're using will have AMD cards in it. So whether it's HP, whether it's a Sony, whether it's a Microsoft Xbox, they're using AMD cards in it. We have a broad range of cards, and really the one that you need to have a look at is that WX7100. And if you're feeling really adventurous, have a chat with Chris and some of the guys on the stands to see how a 7100 works when you have a dual setup, because having that slim profile allows you to put 2 GPUs in there and very quickly scale. Now, there's one thing that's definitely worth mentioning, and that's we are so confident with the cards at AMD, the GPU cards, that we go far behind the far beyond, not behind, beyond. If this wasn't a live stream, that'd be great to edit out. But we go far beyond the industry standard, and we add an additional 7 years onto our limited warranty of the AMD GPUs. So that's how confident we are with the AMD GPUs, so it's definitely worth having a look at in more detail. Now again, a couple of links that were worth mentioning throughout the day, throughout the morning, but pro.radeon.com is where you can go and get ProRender, install it, and also find out some of the other technologies we're working on inside of the Radeon professional range of cards at AMD. So that's kind of me done for my slot, a couple of minutes late, but what I'm going to do is now hand you over to Chris. So whilst Chris is getting set up, Chris is going to run through how Unreal with Enterprise is being used. He's going to give you a couple of customer examples in the VR world of how Unreal is being used. Like I said, it's definitely worth going to look at the McLaren demo that's up on the stands at the minute. And then at the end, he's going to go through a good example of a workflow with inside of Unreal. So thanks for pretending to be interested. It's very much appreciated. And I'll hand you over to Chris.